Hello friends, today we are going to describe a problem which is the determination of whether a number supplied by a user is a perfect number, and we need to know beforehand the logic rather of the perfect number. So what is a perfect number? So we need to know the logic of the perfect number, that is any number which has its factors which add up to the number itself, except the number itself is called a perfect number. That is, if the factors of any number except itself add up to the number itself, then the number is perfect. Otherwise, the number is not a perfect number. Suppose if we take this number, just an example to show you. Suppose this a number is 4. So 4 has the factors including 1, 2 and 4. So these are the possible factors of 4. So if you just leave it aside, this 4 itself, so we are left with 2 only factors. So this 1 and 2 are the 2 factors which will add up to 3, and 3 will not be equal to 4. So they are not equal. So this 4 is not a perfect number. So this is the logic of a perfect number. Suppose we take a value to show you whether 6 is a perfect number. Suppose 6 has a factor 1, 2, 3 and 6. So these are the possible factors of 6. So you always leave it aside, the itself part you leave it aside. So you leave the itself part aside to get all the other factors. So then add them up. 1 plus 2 plus 3 gives you 6, which is quite evident that the result is equal to the number itself. So 6 is definitely a perfect number. So this is the logic of a perfect number. We have implemented this logic to determine whether a number is a perfect number by using the concept of functions, user-defined functions. So let's get started with the code explanation part, and afterwards I will put some sample values in order to make you understand what are the details into it. So let's get started. So this is the hash include stdio.h part. Then we have taken the function prototype, written the function prototype in this manner, that is int is perfect. Is perfect is a name which is given by the programmer, that is in this case I am the programmer, so I have given the name is perfect. You can give any other name of your choice, but the name should be tallying with the operation you are performing. So you can give any other name which corresponds or which conforms to the logic of the program. Int is perfect. Int is the data type of the argument, then the int main section. Then we have declared 2 variables, that is int n and p. Printf, enter a number, user gives a number. This number is to be tested whether it is perfect number or not, and this p is equal to is perfect. So in this line we are calling the function is perfect with the actual argument n, and whatever is returned from the function will be stored in the variable p in this manner. So after that we have written a if else checking portion in which I have checked like this. I have just written the logic in this manner. If p equals 0, printf not a perfect number. So we have implemented the logic in this way. In order to understand the entire logic, you have to go to this section, that is the function definition, to know what I have done over here. So let's just read out these lines. If p equals 0, it will print not a perfect number, else it will print a perfect number, then return 0 and closing brace. Now we come to the function definition part, where we have used the formal argument x, and this n value, the value of this n will be copied to this x by the logic I have described in the previous video. And int I sum is equal to 0, f is equal to 0. These are the variable declaration and initialization part. And this let me see what I've done. For I is equal to 1, I less than x, I plus plus. So I have written if any I value that is starting from 1 and less than x, because why less than x? Because I have already explained it to you that the factors which need to be determined will always leave aside the factor which is the number itself. So x will be left aside. So we have not taken the x. So if x would have been taken, I would have written in this manner, I less than equal to x. So I will not, since I will not consider x, I have written in this manner, or the factors will be counted from 1, because we have taken the factors from 1 to any other factors which is not equal to the number itself. So we have started our iteration from 1 to any number, to a number which is less than x. So less than the number itself. So I is equal to 1, I less than x, I plus plus. Then comes if checking portion. We will see that whether x is divisible by the I value, respective I value in that respective in that particular iterative step. So in the first iteration, we will take the I value to be 1. In the second, suppose we are going to 2, then we will divide this x 1 by x by 1, 2, 3, etc. and see whether any I value is a divisor, is a perfect divisor of this x, because in order to be a number which is a factor of x, we need to check whether this operation, this x modulo I, this x modulus I will yield a result 0. If it yields a result 0, then definitely we can conclude that there will be no remainder in the operation. So the number I perfectly divides x. So I will be a factor of x definitely. So in that case, we will consider those to be the factors, and whatever is the value of sum, the 0 will be and whatever is the value of the I will be added to the sum value, which is initialized to 0 at the beginning of the function definition. So sum is equal to sum plus I. Will update the value of sum. In this way, the iterative process goes on, and when we come out of the loop, we will just check if sum equals x. Suppose if sum f was initialized to, this is a conditional variable. Suppose this is a control variable rather, and this control variable is taken to be a f, like a flag variable. We have taken, we have initialized 0 into it, and if the number corresponds to the sum value, if the sum which comes out of this iterative process is equal to the number itself, then the condition of the perfect number holds. That's why in that case, I will just change this, change the value of this control variable f to 1. Otherwise, we will not change the value of f. F will remain as 0, and then I will return the value of f in the last expression statement and come to the closing brace of the function definition. So I will just put some sample values in order to make you understand perfectly what I have done in this program. So I will put some sample values in order to do a dry run sort of thing. So this let's suppose the user enters a value of n to be, suppose the perfect number, we have already seen that the perfect number 6 is the perfect number. So in this case, we need to see whether the 6 comes to be a perfect number according to the programming logic which I have used in this program. So suppose n is equal to 6 supplied by the user. So this n will be passed as the actual argument to the function is perfect, and the program control goes directly from this line to this line. So this int is perfect function definition has a formal argument of x. So whatever is the value of n will be copied into the x. This is an example of call by value. We will discuss them in detail later on. So n is equal to 6 means x is equal to also 6, because this is the formal argument, which is nothing but a copy of the actual argument. So int I sum equals 0, sum equal to 0, f is equal to 0. This is the condition variable or the control variable which controls the logic of any number to determine whether that number is perfect. So this sum is initialized to 0 beforehand. I is the loop variable or the iteration variable. F is equal to 0 is the condition or the control variable. And this is the iterative logic. For I equals 1, I less than x. Let me see. For I is equal to 1. I is now 1. Sum is equal to 0. Fact is equal to fact. No, not fact. This is f. F is equal to 0. So now we will start with the value of 1 for I. I is less than x. Let us check. X is 6. So I is less than 6. Condition holds if x percent I equals 0. X percent 1. X percent I means 1. Yes, x percent 1. 6 is the x value. So 6% 1 is definitely 0. So this condition holds. So sum will be added by 1, that is the I value. So sum becomes now 0 plus 1 to become 1. Now I plus plus means I is equal to 2 less than 6. See, let us see x percent 2. X percent 2 means when x is divided by 2. 6 is divided by 2 to give a remainder. 6 when divided by 2 gives a remainder of 0. So this is also yielding a remainder 0. So this 2 will be added to the sum again. So sum will be updated now to a value of 1 plus 2, that is equal to 3. Now I becomes 3, which is less than 6. X percent 3 means 3 divides x perfectly. So we get a remainder of 0 yet again. So the remainder again comes to be 0. So this condition again holds. So 3 also becomes the factor of 6. So sum will be again updated to a value of 3 was the previous value of sum, and this 3 will be added to the previous value 3 to give a value now 6. So sum is a value of 6 now. Now I is equal to 4, definitely less than 6, but x percent 4, that is 6% 4 will yield you a remainder of 2. It is not 0. So it is not 0. So this if quotients logic will not work, and that's why sum will not be updated in this step. Then I plus plus once again, I is equal to 5 less than 6, perfect. X divided by 5. X divided by 5 will yield a remainder of 1, which is not 0. So this is also violating this condition. So this if will not be executed, then sum will not be updated. So sum is now only remaining to be 6. Now comes the increment part. To increment I by unity, and I becomes 6. So 6 is not less than 6. Condition doesn't hold. We come out of the for loop, and now let us check if sum equals x. If sum equals x, what is the value of sum? Sum is 6 now. And what is the x value? X was 6, and that's why we see that sum value is just equal to the value of x. So in that case, this condition holds, and f is now, f was 0 previously, now f will become how much? F will become 1. So f will become 1, and after that we will return the value of f to the calling module, and f, the whatever is the value of f, will go into the variable p. Now we come to this line and check if p equals 0, then we are going to print not a perfect number. But since we have returned the value of f to be 1, and p stores now a value of 1, then since p has a value of 1, we come to this else portion to print a perfect number. So the result will be a perfect number. So 6 will be a perfect number according to the output of the program. Then return 0, closing brace of the int section of the main section, and then in this way we see that the result is now coming to be a perfect number. So 6 was definitely a perfect number because 1 plus 2 plus 3 except 6 is another factor which is to be left aside. Now 1 plus 2 plus 3, these are the three possible factors of 6 except the number itself. So they add up to 6. 6 is equal to 6. So 6 is equal to 6. That's why This 6 is definitely a perfect number and the output is also a perfect number. So, the program logic is perfectly okay and alright, and it is ready to be run on the computer system. So, if you have any doubts or queries pertaining to this program, you can well post your doubts and queries into the comment section so that I can address them. Thanks.